Hi, welcome to my video on factoring or factor with radicals. Factor each radical. Notice now that these numbers are belonging to the irrational, so we're factoring over the what we call the real numbers, R, over the real numbers. Before, all of our factoring was related to the integers or rational numbers. But now we have irrational numbers, so we're factoring over what we call the reals. And that means that I can take out a common factor by GCF. Notice there's a GCF, so that's the first rule in factoring. So when we go to factor, the first rule is look for the GCF. Notice that there's a root 2 here in this term and a root 2 here. So we'll take the root 2 out. So root 2x divided by root 2 is x. And 3 root 2 divided by root 2 is 3. And in this one, I have root 11 is a common factor. Root 11 divided by x is x. And 3 root 11y divided by root 11 is 3y. So the GCF is still true no matter how we factor. I always look for the GCF first. C, I'm looking through and I see root 3 in every term, and I see a 10 as a factor. So I see a 10 root 3 as a GCF. So 10 root 3, x divided by 10 root 3 is x. Negative 20 root 3y divided by 10 root 3 is a negative 2y. And 10 root 3 divided by 10 root 3 is plus 1. And we also have a root 3 in each term. That's the numerical. And we also have an x in each term, but we take the smallest exponent of 1 because x is in each term. So 3x squared divided by root 3x squared divided by root 3x is x, plus root 3x divided by root 3x is 1. And this is a little bit different. We want to factor this, so notice we have a difference, but if you think about it, this is x squared, subtract, and we need a square. So what number do we square to get 2? Well, that's root 2. So this is the difference of two squares. So that's x root 2, x root 2 with a plus and a minus. Because before we couldn't do this because we were factoring over the integers. Now we are factoring over real numbers. We can use a root 2 times root 2 is 2. And the plus minus cancels out the middle term, adds up to be 0. And this is the same here. This is x being squared, subtract root 5 being squared. That's the difference of two squares. So here we go. We got an x and an x. Root 5 with a plus and a minus. Difference of two squares. And in G, I have 4 terms. So when I have 4 terms and I cannot, none of them can be added because none of them are alike, I group them as 2 and 2. So I take an x out of the first term. It's a GCF. That's x minus 2. I see a root 7 common in the next two, so I take out, remember, whatever that sign is, that's what you put here. So that's a root 7, a plus. Root 7x divided by root 7 is x, and negative 2 root 7 divided by root 7 is negative 2. Notice in each of these, we have x minus 2 is a binomial, is common. So when I divide x minus 2 into this expression, I get an x. When I divide x minus 2 into this expression, I get a plus root 7. So if you did the FOIL on this, first, outside, inside, last, you will come up with this. And the last one, I see a root 5 and a root 10. Remember, root 10 is made up of 5 times 2, which is root 5 times root 2. So root 5 is monomial GCF. So root 5x divided by root 5 is x minus root 10 divided by root 5 is root 2. Because if you multiply these two, you get root 10. Practice means pause the video, and work each of these out to see if you can factor over the real numbers now. Here we go, do one at a time. And press playback when you get it done. Root 3 is common, so take it out. GCF, I get an x minus 4. I see root 6 is a common GCF. Root 6 divided into root 6x gives you x. Root 6 divided into 7 root x g is a 7g. And I see root 2 is common. I see a 7 is the smallest number. 7 is a factor in 21 3 times, so 7 root 2 is the monomial GCF. So that gives me an x. 21 root 2a divided by 7 root 2 gives me a plus 3a. Subtract root 2, 7 root 2 divided by 7 root 2 is a minus 1. Note we have 3 terms here, so we have to have 3 in here after we take the monomial out. And I see a root 5, and I see an x as a GCF. So root 5x squared divided by root 5x is x minus 2 root 5x divided by root 5x is just 2. And we have, again, looks like we have an x squared minus. So what number do we square to give us 3? So it's root 3. So it's a difference of 2 squares. Notice the difference of x squared and root 3 squared. So it's an x and an x. Root 3 plus minus. And the same here, I have an x being squared minus, oh, that's a square, not a cube, and that's root 13. Root 13 squared gives me a 13. So again, that's the difference of 2 squares. Difference of x squared, root 13 squared. So x and x, root 13 plus minus. And I'm in a habit when I do the difference of 2 squares that I always do the plus first and then the minus, because if anything is going to factor further, it would be the minus, not the plus. Number 7, 4 terms, root 2, you can't add any of these, none of them are like terms. So we go 2 and 2. So in the first 2 I take out an x, it's GCF, so x squared divided by x is x, plus 3x divided by x is plus 3. I have a negative right here, so I take a negative. Automatically, whatever that sign is, when you have 4 terms, you take whatever that sign is, you put it there. And I see between these two, I see a root 2. So negative root 2x divided by negative root 2 is just x. And a negative 3 root 2 divided by negative root 2 is a plus 3. Notice this one has to be the same as this one if it's going to work. So the binomial GCF is x plus 3. So x times x plus 3 divided by x plus 3 is just x. And a negative root 2 x plus 3 divided by x plus 3 is negative root 2. And it's, again, if you FOIL this, you'll come back to this expression up here. And in here I see a root 7x. And I notice that root 14 is made up of root 7 times root 2. I'll just write that down. Now I see root 7 is my GCF. So root 7x divided by root 7 is x, plus 3 root 7 times root 2 divided by root 7 is 3 root 2. And just check back. Root 7 times x is root 7x. Root 7 times 3 root 2 is 3 root 14. Perfect. Hope you enjoyed factoring, because this is not shown that often, factoring over the real numbers with radicals. But I like to show it because somewhere in the math up above, in the higher grades, you will use this. You will use it. So ask your teacher about it. It's good to know how to do it. Or good, again, what we learned earlier on, I keep reviewing and practicing so that you won't forget it. If you like my video, click on the like button, the subscribe button, the notification bell, because there's more videos coming your way. And visit my math website, www.mathfullyexplained.com, to find more information about me, videos, and content. and the content is on my YouTube channel, Math Fully Explained. Hope you enjoyed my video. Thank you very much. Bye-bye.